as literals. How C constants are classified. We discussed about the classification of C constants in the previous class. So C constants can be classified into numeric constants and character constants. Numeric constants can be in turn classified into integer constant and real constant. Character constant can be classified as single character constant and string constant. So this is how we classify constants. Now we will discuss integer constants. So what do you mean by an integer constant? It is a whole number which contains sequence of digits. So an integer constant refers to sequence of digits. Okay. So that it can be represented in three forms. So we can represent an integer constant in three forms. What are the three? What are those three forms in which we can represent an integer constant? What I told, an integer constant is a whole number. So there are three representations for an integer constant. So what are those three? It is decimal form, octal form, and hexadecimal form. So these are the three forms in which we can represent an integer constant. So we'll discuss one by one how to represent an integer in decimal, octal, and hexadecimal. So first coming to decimal integer constant. So what do you mean by decimal integer constant? So it is actually decimal integer. They are going to consist of set of digits 0 through 9 preceded by an optional minus or plus sign. If I say decimal integer constant, so what that integer constant consists of, that is digits 0 through 9. So if you want to prefix the sign to that that is constant, you can prefix it by having plus or minus sign by default. That means if you don't specify the sign for the decimal integer constant, by default it is treated as positive number. If you want to give explicitly the plus sign, you can give it. Okay. So these are the rules for constructing decimal integer constant. So it must have at least one digit to tell it as a constant. Okay, and it should not have decimal point. If you give a decimal point for an integer constant, it becomes a floating point constant or real constant. So whenever you write any integer constant, see that it is a whole number without decimal point. It should have sequence of digits. Any digit you can frame, that is the 0 through 9, and it must have at least one digit to tell it as a decimal integer constant. And it can be either positive or negative. If you are not specifying the sign, in that case, it is assumed to be a positive number. You should not write any special symbols, a blank spaces, a comma within an integer constant, decimal integer constant. And the range for integer constant, it is minus 32,768 to plus 32,767. So this is for 16-bit system. I told it's an exceptional type of constant. It is dependent on the machine. So if you consider a 16-bit system, what that 16 signifies is the processor width or ALU width, meaning that processor is capable of performing 16-bit operations or perform operations on 16-bit data. So that is the meaning of 16-bit system. If you are taking a system which is able to perform 16-bit operations, so in that system, integer size will be 2 bytes. Okay, for a 16-bit system, size of integer is 2 bytes. Then what is the range of values we can have for integer? It is minus 32,768 to plus 32,767. So in general, you can just take minus 2 to the power of n minus 1 to plus 2 to the power of n minus 1 minus 1. Okay, where n is the number of bits. Okay, so here if you take 16-bit system, you can replace n with 16. So what you'll get, minus 2 to the power of 16 minus 1 2 plus 2 to the power of 16 minus 1 minus 1 will result in this range. So the minimum number we can represent is minus 32,768. Maximum number we can represent for an integer is plus 32,767. Okay, so just remember, integer size is machine dependent. So for a 16-bit system, throughout your course, we'll be discussing an integer size with integer size of 2 bytes only. That is, we are assuming that it is a 16-bit system. Okay, the range of values we can represent is the signed values. It is minus 32,768 to plus 32,767. So just replace n with 16 here. So you'll get this result. Okay. How actually it is, once we go to the data type, we'll discuss in detail how the integers are represented in memory. All those details we'll be discussing. So for the time being, just know these rules for constructing decimal integer constant. It must have at least one digit. It should not have decimal point. It can be either positive or negative. If you are not specifying the sign, it is assumed to be positive. You cannot give any special symbols within an integer constant. And the allowable range for integer constant is minus 32,768 to plus 32,767. Few examples you can see 350. You can observe in the first example we are not specified the sign, but first number is treated as a positive number, and explicitly we have given plus sign here to indicate it as a positive number. This is also fine. It is a valid integer constant. Minus 8,000, a negative number we have given. So these are few examples of decimal integer constant. So just observe each digit. Each digit is 0 through 9. So each of the integer constant, decimal integer constant, is framed using the digits 0 through 9. Optional plus or minus sign is given. If you want to interpret that number as negative, you have to prefix minus sign to that number. Okay. So this is about decimal integer constant. Coming to another form of integer constant, that is octal integer constant. An octal integer constant, it may contain any combination of digit from 0 to 7. Okay, it is octal number system we are dealing with a leading 0. So any integer constant prefixed with 0, that is treated as an octal integer constant. That means that number is represented in octal number system. So that is the meaning. An octal integer constant consists of sequence of digits, but it is 0 through 7 only. Okay, we cannot represent 8 in an octal number system with a leading 0. Say for example 0, 1, 2, 0, 1, 0. Just observe here, we have prefixed integer 0 to the number, to the decimal integer, to represent it in octal number system. So 0, 1, 2 represents what decimal value? How to find it out? So what is the decimal equivalent of 0, 1, 2 and 0, 1, 0? How to convert a number in octal to decimal? You know, octal to decimal conversion and vice versa conversions. How to do the conversion? I've given two examples for octal integer constant. Okay, how to represent an octal integer constant? We need to prefix integer 0 to that constant. That becomes an octal integer constant, not decimal integer constant. Okay, so how actually we can find out the equivalent decimal integer given with an octal integer? Just write in powers of 8. So each digit in powers of 8 you need to write. So here it is 1. 1 into 8 raised to 1. Okay. Plus 2 into 8 raised to 0. What is this value? What is this value? This is equivalent to, it is 1 into 8 means 8 plus 8 to
10.
the power of 0 is 1. 8 plus 2, you got the answer as 10. See, given with an octal constant, how to convert it into decimal? So in powers of 8, okay, you need to multiply each digit. 1 into 8 raised to 1 plus 2 into 8 raised to 0 will result in 10. So decimal 10 is equivalent to what value? 12 in octal. Okay, this is how you'll do the conversion. Given with 10, decimal 10, how do you convert this into octal? Just go on dividing it by 8. I am having a data which is in decimal. I need to convert it into octal. How we are going to convert? Just keep on dividing that number by 8. See, 8 ones are 8. You are getting the remainder as 2. So this is 12. That's what you are seeing. 12 in octal is equivalent to 10 in decimal. Similarly, 10 you are having. 10 in octal is equivalent to what decimal value? 1 into 8 to the power of 1 plus 0 into 8 to the power of 0. What is this value? This is 8,
8.
right? 8 cannot be represented in octal number system. What are the digits we can represent in octal number system? It is only 0 through 7. So you can observe the digits, any sequence of digits given. So they may give you some list of constants. They may ask you to identify which are all the valid constants are in and invalid constants. If you see any number as say 128, 0, 1, 28. If this number is given, you need to tell this as invalid constant. Since you are prefixing it with 0, we need to interpret this number as an octal constant. But in octal number system, you will not be having digits 8. So only 0 through 7 you can have the digits in that constant. So as an example, I've considered two constants which are octal integer constants. How to convert an octal integer constant to decimal? So just multiply each digit in powers of 8. So for 10, it is 8 decimal. How to convert it back? You just take 8, divide it by 8. Just see 8 ones are 8, remainder is 0. Okay. 10 in octal is equivalent to 8 in decimal. So this is about octal integer. Okay. Coming to another form of integer constant, that is hexadecimal integer constant. So what are the digits we can represent in hexadecimal integer constant and how we are going to represent it? It is, we are going to prefix 0x. It is not O, okay? It is 0x in lowercase or in uppercase. So x can be given either in lowercase or in uppercase. For the integer constant, if we are going to prefix this 0x, then that integer constant is treated as an hexadecimal integer constant. Okay, if you are prefixing 0, it is octal constant. If it were to be 0x prefixed to an integer constant, then it is treated as an hexadecimal integer constant. Just see, in addition to 0 to 9 digits, it may also contain alphabets A through F. A to F is either in uppercase or in lowercase, which is going to represent the numbers, that is 10 to 15. 0 to 9 we can have, or 10 to 15. Hexadecimal number system is, it is 16-bit system. Octal, it is 8-bit 8 number system, and here it is 16. So if it were to be 16, in that case 0 to 15 can be the numbers we can represent. For 0 to 9, the digits can be used, and 10 to 15, how we are representing these values? Through the alphabets A to F. Okay, these alphabets can be appearing in an hexadecimal integer constant, where A to F, the values we can, that name we can write it either in uppercase or in lowercase. So just see examples for hexadecimal integer constant: 0x10, 0x1c. So these are few examples I've given for a hexadecimal integer constant. Can anyone tell what value this is representing? What is the decimal value? How to convert an hexadecimal number to decimal? See how we have done the conversion for octal to decimal. Similarly, tell me.
16 power 0, ma'am.
Yeah,
16
in
power
powers of
0,
16.
16
In
power.
powers of 16, we need to perform 1 into 16 raised to 1 plus 0 into 16 raised to 0. What is this value? 16 to the power of 0.
16.
So 16. 16 in decimal is equivalent to what value in hexadecimal? It is 10h. That is
10.
0x 10. 10 in hexadecimal. So 1c. What is the value it is representing? 1 into 16 to the power of 1 plus c means what is the value? C
12, ma'am.
A 12, right? A means it is 10. You can just see here in the above point. I've mentioned alphabets A to F or uppercase A to F or lowercase A to F can be used to represent the numbers 10 through 15. 10 for A, okay, 11 for that we use
28, ma'am.
the letter B. For C it is 12. So 12 into C means it is 12. 12 into
12
16 to
into
the power of
16
0.
power
Good.
0.
28. Yeah. It is
28.
28. Good. Okay. This is how we are going to do the conversion. So given with 28 decimal, you know how to do the conversion. Just divide it in with 16. Keep on dividing the number by 16. Keep the remainder. Whatever the number you will get, that will be the result. So 28 you are having. Just divide it by 16 to do vice versa conversion. So 16 ones are 16. You are left with 12. How do you represent 12 in that is hexadecimal number system? It is C. 1C.
C, ma'am.
1C is the value got. Correct? Yes. So decimal number to convert to hexa, we'll divide that number by 16. So given with hexadecimal number to do the conversion to decimal in powers of 16, you need to multiply each digit. Okay. So remember these forms. An integer constant can be represented in three forms. Which are those three forms? It can be a decimal integer, it can be an octal integer or an hexadecimal integer. And how to represent an octal integer? We need to prefix that integer constant by 0. How to represent an hexadecimal integer constant? We need to prefix that integer constant by 0x. So don't get confused with the constant, and now I will be discussing the format specifier used for representing these numbers. Okay, kindly don't get confused with these two. Remember, it is 0. It is not letter O, it is 0. Getting here also. If you are prefixing integer 0 to the number, it is octal. If you are prefixing 0x, where x can be in lowercase or uppercase, then that number is interpreted as an hexadecimal integer constant. Okay. And already you know the format specifier which you can use for printing a decimal integer. Which is the format specifier I have used to print a decimal integer? Yes. What format specifier you use for printing a decimal integer?
Percentage D.
Yes, right. Percentage D is the format specifier where D indicates decimal integer. If you want to print an integer constant in decimal form, then you need to just use the format specifier percentage %d. So now you just see what are the other format specifiers which we can use with respect to an integer constant. Percentage %d for decimal integer. Percentage %o I can use. It is not 0. Remember, data type character we are going to give. Followed by percentage, what we are going to give is a data type character. D indicates decimal integer, O indicates octal integer. We need to give O if you want to print the data in octal form. So if I want to print in hexadecimal form, I'll use X. Each must be in lowercase. As I told, data type character what you give in the format specifier, it should be always given in lowercase. Okay. See what are the three forms we are going to represent, and what are the format specifiers you are going to use. It is percentage %d for decimal integer, percentage %o for octal integer, percentage %x for hexadecimal integer. So let me give few constants. Same constant let me give. I'll give 10 comma 10 comma 10. Okay. So let me give this value. So now we shall see what will be the result. Can anyone tell what will be the result? If I give percentage %d space
10,
percentage
comma
%o,
8, comma 16.
10 comma
8, comma 16.
8 you'll get for 10. In octal, 10 in decimal I have given. In octal,
Invalid.
no. Are you able to understand the arguments I have given in printf? In the first argument for printf, I've used list of format specifiers. In the second argument, I have given the integer constant. What type of integer constant I have given in the list?
12, ma'am. 12, 12.
Yeah, correct. See, first 10 percentage d means decimal integer is to be printed. What is the representation I've used in the second argument list? It is 10 only. It will be represented as it is. 10 will be printed as it is since we have used
10,
percentage d.
12, and
Yeah. For how to convert a decimal integer to octal? Divide it by 8, right? If you divide 10 by 8, what you'll get? 12, right? So 10 in decimal is equivalent to 12 in octal. You'll get 12. What about 10 in decimal? What is the representation in hexa? What is the representation in hexadecimal?
1A, ma'am.
No. How many digit? What is the range of values we can represent? Range of digits? It's 0 to
So,
9 and A to F, right?
yes, ma'am.
10 if I give,
Yeah.
A, right? See, we'll compile this and we'll try to execute this and see the output. Are you able to see the output? What value I had given? See, for the first format specifier, what value it has printed? 10. Since I've used the format specifier percentage %d, it has printed 10. So the second format specifier percentage %o means this decimal integer I have to represent it in octal form. What is the value it has printed? 12. 10 in decimal is equivalent to 12 in octal. So 10 in decimal. So what is the representation in hexadecimal for 10? It is A. Correct? Are you getting? what I
Yes,
have
ma'am.
given in the
Yes, ma'am.
argument list in printf and how it is represented if you are changing the format specifier. So depending on in which form you want to represent the integer constant, accordingly you can make use of the format specifier. Percentage %d for having the integer constant in decimal form, percentage %o in octal form, percentage %x in hexadecimal form. So let me just write here one more printf statement. Try to guess the output for this. I'll give %d, %d space %d, comma, okay. I'll give 12, comma, 0x12, comma, 0x12. Yes, the output was, sorry, it is not 0x, it is 012 and 0x12. Now tell me, in the second argument onwards, in printf, in the second printf statement, first argument is the control string, which contains list of format specifier. Second, third, and fourth argument in printf, they are constants. What type of constants they are? Integer constants. What is the form in which I have given the first integer constant? It is in which form?
Decimal. Decimal.
Decimal.
Decimal
Second
one.
one, I have prefixed 0 to it. It is what type of constant?
Of
Octadecimal.
Octal. Third one, it is
Hexa.
hexadecimal, right?
Hexa.
Now,
Yes, ma'am.
but what is the format specifier I've used? I've used %d for each
Percentage
of
D.
these. That means in which form I want to print each of these integers?
Decimal.
Integer.
Decimal integer, right? Now tell me what will be the output. What are the three values that gets printed for second printer? Let me comment this first printer. Tell me the output if I execute
12,
this printer.
10,
12, 10,
Hmm.
18, ma'am.
Convert.
18. 12, 10,
Yeah.
18.
Very good. Okay. So 12, it will be printed as it is. 0, 1, 2 means it is in octal. Convert octal to decimal. It is 1 into 8 to the power of 1 plus 2 into 8 to the power of 0. What you'll get is 8 plus 2, 10. 12, 10, and this is 18. 1 into 16 raised to 1 plus 2 into 16 raised to 0 means it is 16 plus 2, 18. So just see 12, 10, and 18 will be printed. Carefully, you have to analyze the printf statement. Just observe what you told is correct. See, 12, 0, 1, 2, it is in octal form. We are trying to print it in decimal. So you'll get the answer as 10. 0x12 means it is an hexadecimal integer constant we have given in the argument list in printf. We want to print its equivalent decimal value. It is 18. Are you able to understand the difference between first printf and second printf?
Yes, ma'am.
Hope. See, I have taken all decimal integers. I am trying to print its equivalent, that is octal, decimal, and hexadecimal forms. Whereas here, I have given the different forms of integer constant. Each I need to print it in decimal form. So carefully you see the formats before guessing any output. Assume they have given a code. You need to guess the output for it. So just see what format specifier is used and in what form the data is represented. Accordingly, you have to guess the output. So carefully you have to analyze the printf. Hope these forms of integer constants is clear. Decimal, octal, and hexadecimal. Okay. Moving on to the next type of constant. It is real constant. Real constant, they are also called as floating point constants. Okay, so real constants can be represented in two forms. Which are those two forms? It is decimal form, or it is also called as fractional form, exponential form, or scientific form. Few references they use the term exponential or scientific, and for decimal representation the other form it is called as fractional. All mean the same. Okay, so decimal or fraction, it is the same meaning. Exponential or scientific, it is the same meaning. So these are the two representations for a floating point constant. Okay, so coming to the rules for constructing the real constant or floating point constant in fractional form. So what are the rules? A real constant must have at least one digit. So to interpret that constant as a real constant, you have to specify the decimal point. If I simply give say 12, so 12 is actually a whole number. It is treated as an integer constant. If you simply give 12, what type of constant it is? It is an integer constant. Decimal integer constant it is. But if I give 12 point, a 12.0, So then this constant is considered as a floating point constant. Okay. If the compiler wants to interpret any of the constant as a floating point constant, see that you are going to give the decimal point. After that, if you want to give 0, you can give, or if you simply want to give just dot, that is also fine. So what is compulsory to interpret that constant as a floating point constant? You have to specify decimal point. Okay. A real constant must have at least one digit with decimal point. So it can be either positive or negative. Okay. If the default sign is positive, if you don't specify the sign, it is treated as positive. No comma, blanks or special symbols are allowed within the real constant. You cannot give any special symbols. It is same as integer constant. The same rule holds here also. Say for example, see, plus 325.34. So this is one of the floating point constant I have given with prefix plus sign to indicate this as a positive number. If you don't prefix the sign, it is treated as positive only. Say 426.0, the minus 32.76. So all these are floating point constants represented in decimal form or fractional form. How do you represent them in decimal or fractional form? We are going to write sequence of digits, then we'll use decimal point, followed by that the fractional part you are going to write after decimal point. So this is the form or notation you are using for writing the real constant in decimal form, yeah, fractional form. So this is the first form we are discussing in this slide. It is decimal form or fractional form. Few examples we are seeing in this slide. So it must have at least one digit. It must have the decimal point. It can be either positive or negative. Default sign is positive. As you can see in this example, the second example, 426.0 I have given without prefixing the sign. If you don't specify the sign, that number is treated as a positive number. If you miss dot, that is the decimal point, then it becomes a integer constant. So compulsorily you have to specify dot, and that is the decimal point to interpret that number as a real constant. Okay. Coming to this is one more example, minus 48.5792. 4 digits after decimal point we have given. Coming to the next form of real constant representation, that is exponential form or scientific form. So what for you are using this exponential notation or scientific notation to represent a floating point constant? So usually we go for this representation if you want to represent a constant which is either too small or too large. So if you want to represent such data which is too large or too small, we can represent that constant in exponential form. Okay. So what is the syntax for representing the constant in exponential? That we'll see. In exponential form of representation, the real constant is represented in two parts. The part which appears before e, we need to use letter e for exponential notation. So whatever you specify before e, that is called as mantissa. Whatever you specify after e, that is called as the exponent. Okay, two parts you find, each part separated with the letter e. So this is the syntax or the general form. We are going to write mantissa part, then e, letter e, even it may be in uppercase or lowercase, followed by that you are going to specify the exponent. Okay, this is the form in which we are going to represent a real constant in exponential notation or scientific notation. So the mantissa can be either a real number expressed in decimal notation or fractional form, or it can be an integer constant. You can specify a whole number here before e, or you can have a real constant represented in decimal notation. Then you are going to write the letter e, followed by that you are going to specify the exponent. Okay, so exponent should be always an integer constant. You cannot write fractional part in the exponent position. It must be an integer constant only with an optional plus or minus sign. For mantissa also you can prefix plus or minus sign. For exponent also you can prefix plus or minus sign. It is optional to specify the sign for either the mantissa or the exponent. So what you have to remember is exponent must be an integer constant only. Mantissa can be either an integer constant or it can be decimal, that is real constant represented in decimal notation. So letter separating mantissa and exponent can be either uppercase e or lowercase e. So we'll see the example. Before to that, we shall quickly go through the list of rules for constructing a real constant in exponential notation. So the mantissa part and exponential part should be separated by letter E. Mantissa part may be in decimal notation or an integer, which may be positive or negative. Default sign of mantissa part is positive. The exponent must have at least one digit, which must be positive or negative integer. And again, default sign is positive. So if you don't specify the sign, neither to the mantissa part nor to the exponent part, they assume if you have not specified the sign, then it is treated as positive number. Okay, exponent is positive if no sign is specified. Similarly, if you don't specify the sign for mantissa, it is treated as positive mantissa. Okay, but remember, exponent must be integer only. It should not be a floating point value. So range of real constants expressed in exponential form is minus 3.4e38 to plus 3.4e38. So what is the value it is representing? E means if you want to represent the number in powers of 10. So that is minus 3.4 into 10 to the power of 38 to plus 3.4e 38. I'll give an example. So I want to represent this value. Say 0 point. Assume I have given 8 zeros. 4, 5, 6, 7, 8. Say 3, 6, 7 I have given. So this is too small number. I need to represent it in exponential notation. How this number will be represented in exponential notation is the number will be normalized. So what do you mean by normalization? Before the decimal point, there should be only one digit, one non-zero digit. So that is called as normalization of the number. So here, this the decimal constant, that is real constant represented in decimal form, it will be converted into exponential notation. So how actually it converts is, it shifts this decimal point towards right. So by how many positions it is shifting? See, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So what is the value you are going to get? 3.67. Okay, E9. It is minus 9. Since we are shifting the decimal points towards right, so we need to decrease the exponent. If we are shifting the decimal point towards left, we need to increase the exponent. So this is the same. E minus 9 means into 10 to the power of minus 9. If you take 3.67 into 10 to the power of minus 9, it is actually 0. This all zeros, 367. Okay, so E means it is 10 raised to minus 9. That is the meaning. Are you getting? So if the number is too small or too large, it can be represented using exponential form. So if you are going to take this constant, this floating point constant, and if you try to represent it in exponential form, this will be the output. Okay, so if you are having too large value, say 3, 6, 7, say some 8 zeros here. Okay, 4, 5, 6, 7, 8. So what is the equivalent exponential notation for this? Can anyone tell? 0.0. Remember, 0.0 I have to give. So 0.0. 3, 6, 7 I have given. 8 zeros I have given. Then I have given a dot, then 0. What do you mean by normalization? Where this decimal point will appear?
3.67.
Yes,
3.6.
we need to shift this decimal point towards left. See, in this example, what I discussed, we are
3.67 into
shifting the
10
decimal
power minus 10.
minus or plus. You are shifting the decimal point towards left.
Plus, ma'am, plus.
Plus 10.
Plus, right?
Plus, ma'am. Plus.
Yeah, 3.67 into E, that is 10 to the power of, how many shifts it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the power of plus 10 it is. That means how to represent it in exponential form. Mantissa part is 3.67. We are using exponent E. This letter E we need to write either in uppercase or lowercase, then plus 10. See, this is called as exponential notation, yeah, scientific notation. So 0.000367, these many zeros, 367 is represented as 3.67 into 10 raised to minus 9. And this large value is represented in exponential form as 3.67 E plus 10. So if you want to verify this, you can just see here. Let me just execute this. Printf, I'll give. Just see what value I'll give here. Just a minute. Person, and what is the format specifier you are going to use for printing a real constant or floating point constant in fractional form? Can anyone tell? If you want to print it in fractional form or decimal notation, a real constant, what format specifier you have used? What is the format
Percentage F.
specifier?
F.
Percentage F, right? F for printing floating point constant in fractional form. If you want to print the floating point constant in exponential form, you need to use the format specifier E, percentage E. Are you getting? To print it in fractional form, it is
Yes, ma'am.
percentage F. To print it in exponential form, it is percentage E. So if I write percentage E, comma 0.8 zeros I have given, 4, 5, 6, 7, 8, 3, 6, 7 I have given. So this is a valid real constant. Since decimal point is there, you can tell that this is a valid real constant. Now, if I just execute this, the same real constant will be represented in exponential notation. So just observe by what value it has represented. 3.67. See, the number is normalized. Normalization means before decimal point, there should be one non-zero digit. That is called as normalization of the number. So here it is normalized 3.67 and up to 6 precision digits after decimal point it has displayed. 3.67 followed by that 4 zeros has been displayed. E, okay, letter E is displayed and minus 9. The 3 digits it has taken for exponent. And it depends on the compiler how many digits it's going to take to represent the mantissa after decimal point and to represent the exponent. So for this it is taking after decimal point in the mantissa part it has taken 6 precision digits and letter E is printed and 3 digits are used for printing the exponent and minus sign is prefix. So since it is we are shifting the decimal point towards right, it is negative exponent we are going to get. So let me just represent this value. Let me give 3.367. I'll give leading zeros here. Followed by 367. I'll give 8 zeros. 5, 6, 7, 8. 0.0 I have to give. Don't forget 0.0 since it is a decimal, real constant. Now what will be the output? If I just execute, just observe what you told. It is 10, right? 3.67. Again, it is normalized number it has printed. 3.67. After that, 4 zeros are printed. Since here the compiler is taking 6 precision digits after decimal point for the mantissa. 3.67, 4 zeros. E. Letter E will be explicitly printed. Then positive sign. It is a positive exponent you have got for this. Plus 0, 1, 0. 3 digits for exponent. I hope you have understood the two parts in the exponential notation. Mantissa part, letter E, then exponent part. For exponent, it will just write, it is going to print explicitly the sign of the exponent. If it is positive exponent, plus is printed. If it is negative exponent, minus is printed. This is how the compiler has printed the floating point constant in exponential notation or scientific notation. Are you able to understand this? Followed?
Yes, ma'am. Yes, ma'am.
Okay. So remember these points. If you want to print the number, an integer constant in 3 forms, decimal, octal, hexadecimal, you are going to use these format specifiers, percentage %d, percentage %o, percentage %x respectively. If you want to print a real constant or floating point constant in fractional form, you'll be using percentage %f. If you want to print it in exponential or scientific form, you're going to use the format specifier percentage %e. Okay, remember this. Where E stands for exponential notation.